So today we are doing the acid properties, right? We are
Okay.
doing the acid properties. So that for acid, we need acid is atomicity, then consistency, isolation, and durability, right? So out of these four, we always want to talk about transactions when we talk about the acid properties, right? We can answer without the transaction as well. The only thing is we need to explain what is a transaction as well in the definitions, right? So atomicity is whenever a transaction is treated as a single indivisible unit, then it's called atomicity. It's not like a single statement, right? I don't know
Okay.
what answer you provided. I forgot now. But the thing is, a transaction you mentioned is a group of statements, right?
Yeah.
Bind it together, right? So what atomicity says that it will be treated as a single unit. That means if your transaction, if your transaction is consist of, let's say SQL1 and SQL2, SQL2 and SQL3, right? Then if it will be treated as a single SQL instead of 3 SQL or a group, then it will
Okay.
be transaction. What does it mean? It means either all the statements will be committed or neither of them will be committed, right?
Okay.
This is atomicity. Either everyone will be, when we say atomic, it does not mean that one by one it will go. It means that this group of queries will be treated as a single unit. It is atomicity. Cool.
Okay.
So the definition that we can say with the transaction in the definition is atomicity ensures that a transaction, this is a transaction, right? So this
Okay.
atomicity ensures that this transaction is treated as a single indivisible unit of work. Okay.
Okay.
So it will be treated as a single statement, and a single statement will be executed or not executed, right? So same thing with this
Okay.
as well, because we have a transaction already. So and transaction has a bundled queries or n number of queries. So either all will be committed or neither of them will be committed, right? And in the
Okay.
transaction, we need to know two things about transaction. If there are transaction going on, right, and transaction will have multiple SQL queries, right? So
Okay.
DQL statements does not make any impact on the transaction, right? DQL, you know, right? Search queries.
Yeah.
So
Yeah.
DQL does not make any impact. The only impactful item that we need to take care of in the transaction is update, delete, insert, right? So that
Okay.
will be DML, right?
Yeah.
And usually we don't do DDL inside the transaction. It's not required. Okay. Then what? Then the thing is, now we are aware of this thing. uh, what is a transaction, right? So transactions, when we start a transaction, then what ends up doing, if you started a transaction, right? Execution of a transaction you started, if you are at line number 1 executing, right? So what will happen, either all will be committed, right?
Okay.
Or no, none will be committed. So
Okay.
if transaction is successful, transaction transaction if successful, then we say that it will be committed, right? And we will write commit as well. We will see in a later in a while. And if transaction fails, right? Transaction success commit, and if fails, then what's the terminology for that? Rollback.
Okay.
Okay, rollback. Very commonly used. If fails, then it will be a rollback. Cool. So
Okay.
this is the first thing. Now we are clear with the transaction, right? Transaction is a group of statements binded together, which will be treated as a single indivisible unit of work. That will be
Okay.
the atomicity. Cool.
Okay.
Clear? Atomicity. Now what about consistency? See, when we talk about the consistency, a lot of people don't, the theoretical part says the consistency ensures that a transaction brings a database from a consistent state to another consistent state, right? But
Okay.
again, this statement, while it's true, does not make sense. Does not make sense as in it does not elaborate what is consistent state, right, and how we achieve it. And
Yeah.
these things it does not explain. So what does it mean by a consistent state, right? So usually on the internet there is an example that if there is a bank and we want to transfer money from account A, from user A to user B, then what needs to be done? The one thing needs to be done is, if I want to transfer 100 rupees, A account balance should be subtracted by 100, right? And then the B account balance should be updated by 100, right?
Okay.
But to make a transaction successful, right? To make this bank transfer successful, these both statements should be executed, right?
Yeah.
So what I will do, I will treat it as transaction, right? I'm making it as T1. Cool.
Okay.
So now this is a transaction. And what transaction do? What atomicity says that either both will be executed or none will be executed, right?
Okay.
So first thing is that I have already put into the transaction. First thing. Second thing is, if let's suppose I have subtracted this amount, so the consistency says if the bank has total amount of total money the bank has is 1000, right? And let's suppose there are only two users, right? A bank balance is 800 and B bank balance is let's say 200, right? Because we have 1000 total bank balance. So if I transfer from one account and transfer it to the second account, then again the total will should be 100, right? 1000, right? So this is the pre-data, and post successful post execution of transaction successfully, the data should be look like this, right?
Okay.
So what will be the consistent? The example usually over the internet says that okay, this amount, the combination, the sum of the amounts from A and B account should be 1000, and from A and B again post successful commit of the transaction should also be 10,000. Oh, sorry, 1000, right? So they usually give this example, but the thing is, it is correct. While it is correct, but it has many checks or checks or conditions. First thing, that the bank, the transaction should be within a bank, right? First thing, and the architecture should be monolithic. Right now in the real life example, when you see, if you send money to someone and it does not reach that particular guy, or if you try to take out money from the ATM and ATM does not have the money, then what happens eventually, that in your statement you will see that minus 100 rupees or 10,000 rupees and then plus 10,000 rupees, right? Have you seen this thing? I'm audible?
No, I didn't get you.
Okay.
Minus?
If you try to send money to someone using
Okay.
Google Pay, using UPI, and if it does not reach to the receiver, then in your bank statement you will get minus 10,000 rupees. If you are trying to send the 10,000 rupees, then you will get the minus 10,000 rupees. And after 1 hour or 24 hours, when the money comes back, again there will be an entry of plus 10,000 rupees, right?
Okay, yeah.
Same goes with the ATM as well. When we try to withdraw the money and the ATM does not has the cash, again the message comes minus 10,000 rupees and then plus 10,000 rupees, right?
Okay.
So this means that as an example it's good, but it's not being used in the real life scenarios, right? Because there are two conditions: monolithic architecture of the database,
Okay.
and second is that the bank transfer is within the bank, right? Not outside the bank.
Okay.
Cool. So this is deceivable. I mean, it's not completely correct. I mean, you can say with the conditions it's correct, right? But a better, I mean, we have already created one database, right? We have created our database, right? We have products, orders, right? Users, right?
Okay.
So we can take example of this as well, right? So what will be the consistency? Consistency means there should be, I mean, the data should be consistent. We have already gone through it, right? And you already know what we use to preserve the consistency. What will be the consistent for my database that we have created for Zomato, right? How the data will be inconsistent if I try to sell a product to a user that does not exist in my system, right? Then my system will be inconsistent, right? Because I'm selling to someone I don't know, and the other thing would be I'm selling the product that I don't have, right?
Okay.
So that thing will make our system inconsistent, right?
Acha.
So how can I make my system consistent? You know the answer. By using constraints.
Okay.
How we have ensured in our system that no order will be created of a user that does not exist, right? If I try to insert into public orders, right? And let's see. We were we are doing this from the day one. So let's check the users. Select asterisk from public users. My bad. Okay, we don't have users table.
No, LECT. LECT.
Okay. My bad. Okay, cool. So we have 1 to 5 users, right? So let me check the orders table. So insert into public orders and then values. Let's say the id, let's make it 1000, and the user id, only 5 users are there, right? So I'm
Yeah,
trying
yeah.
to take user 9, and then product id I'm trying to take 1, which is valid. Amount can be 100, which is valid. And then now and now, right? But if I try to insert it, what will happen? It's violating the constraint, right? Or the
Yeah.
user key, it
Okay.
is a foreign key.
Yeah.
Okay, it is mentioned, right? It's a foreign key constraint that it's violating. So my system will be consistent, right? So this is what
Okay.
consistency means. That, and the consistency will differ for different platforms. It will be different from the payments application. It will be different for a blogging site consistency. It will be different for social media apps. It will be different from banking applications. So
Okay.
consistency of your system, database system, right? It is
Hmm.
not like it is not loose something. I mean, it is loosely loose item. It will be different for everyone, right? And
Okay.
so now you understand. And how we ensure, how can we ensure consistency? by
Constraints.
by adding the constraints, right? Isolation will take some time, we will cover it later on. And durability, right? What does it mean? Okay. Let us talk about the transactions as well, right? What will, okay, we will see the example of these three, and then we'll go to the isolation, right? Durability just says one thing, that and see, we'll going to duration, see the example as well. If this is transaction going on, right? First thing is that I have created a user, or I have created a product. Cool. The next line in the transaction was to insert to insert a row in the orders table where the user does not exist, right?
Okay.
So what will happen? The entire thing will be rolled back, right? Entire transaction will roll back, right?
Okay.
Because our atomicity says either all statement will execute or none of them will execute, right? And
Okay.
this SQL, this second SQL cannot execute because it was violating the for key constraint, right? So asset
Okay.
properties, whenever we say, we talk with relation to transactions. Cool. Then durability. Durability also will say, talk about the transaction, that durability guarantees that once a transaction is committed, cool, the
Okay.
changes will be permanent. And then the thing that you have mentioned, that it will survive any system failure, power outage, crashes, right? Or system reboots. Because whenever we use a machine in Java, any
अच्छा.
language machine, why do we require the database in the first place, right? We have already gone through it. Because we wanted something that will be stored, the data. We want something that can store the data, right? Because we can replace the machine and we can restart the machine when we add a new data or new system, we add the new functionality. We have to reboot the system, and the languages stores the data into the RAM only, right? And RAM data will be wiped out as soon as we unplug the power, right? Or restart the
Hmm.
application, right? So that's what's happens with the RAM and with this memory that we want to use when that we use while working with the Java application or any server, right? So that's why we wanted something that we can persist, right? So that's why the
Okay.
durability is there, and the durability is the permanent memory, right? And the permanent memory will be SSD, right? HDD, SSD, whatever you are using, it depends on your system configuration. Then it would be SSD and or HDD. Cool. So the one thing comes that, okay, so it means that, I mean, you should have asked this question, that you are saying that all these statements will execute or none of them will be executed, right? So where will this statements, I mean, let's suppose one, I have created a row, right, in products table, where that data will be stored. Because if when we do the commit, then only it will go to the persistent space. Till then, where will it be stored, right? The answer will be same. Only three memories are there in the system, right? Hard disk, that can be HDD or SDD, then the RAM, and then the cache, right? So
Yeah.
this data will be in the cache, and we don't call it heap. We in the Java we call the memory heap and non-heap. In this we call it buffer only.
Okay.
While we have conversation regarding the database, we call it uh,
Oh.
buffer. Okay, give me 1 minute. Okay, restarted the recording. So what eventually happens when we are doing the consistency, when we are looking at the consistency part of the ACID properties, then we know that okay, these statements will be whenever we will call the commit, right? Then only this data will be committed to the permanent storage, right? That would be the hard disk drive, SSD or HDD, right?
Okay.
So by the time when we call the by the time we haven't called the commit, then that memory will be stored in the buffer, right? That would be the RAM. And
Okay.
if we commit if we do the rollback, then that thing will be deleted, right? It will be like a dangling pointer or the dangling memory which can be used for deletion, right? Which can be used to rewrite. So that's how the transaction works, right? So now
Now,
let's see two things.
durability, like no, durability in the sense like once you have done the transaction, okay, after you do the commit, then only it's going from cache to it's becoming persistent.
Yes, if you don't
So,
see the
so
commit thing will work only with the transaction. If you are executing a single line of statement, we never have to write the commit, right?
okay.
Okay, so I will show you how it works, right? I think you haven't worked with the transaction into the database, right? Practically. So have you worked with the
No,
transaction?
after we do commit,
Yes.
if we have the power crash, if the data is in the cache only.
Yeah.
Like now you lost the power, but you pressed commit
See,
from you
don't use the cache, right? Because if you use
buffer
yeah,
buffer
yeah, buffer is good.
buffer.
Yeah.
So you have done the commit, but it's there in the buffer, but power gone now, and it is not made persistent. Now will the database, that is what is called, you are calling durability. Now once the power comes back, now DB RDBMS will ensure that this commit is made persistent.
No.
Okay.
If commit is successful, if data has been written to the hard disk or SSD, right?
Okay.
Then after it has been written into the hard disk, then only it will be available for you after the power crash, after the system crash, or after the reboot. If you are saying that from buffer you wanted you have just enter commit, right? You have enter commit, and then this is SDD where data needs to be stored, right? And before completion of this you have the power outage, right? Power
Yeah.
outage, PO. Then the commit is not successful, right?
Yeah, Acha, commit in the sense you are saying moving to a
Okay,
persistence is what is called commit.
wait. I will show you how practically it's done, right? Then it will be easier for you to understand. So, okay, so let's remove this. Okay, we will come to this later on, right? So the
Okay.
durability just means that if I commit the data, then it will be persistent, right? If it will be visible after the power crash and after all those things that you have mentioned, right? After reboot, power crash, power outage, everything it will face. Cool. And it does not need to be in a transaction. We are just using the transaction because as an advanced user we are using it, right? Otherwise we
Okay.
execute a single query as well, that too gets into the SSD, right? I mean the permanent storage. All right.
Okay.
So isolation, like you mentioned, it usually the way how the multiple transactions will interact to each other and how the transactions will impact each other's data visibility.
Okay.
That's the isolation level, right? But if we go for the technical terminology, then the isolation level will be responsible to ensure what we use other terminology when multiple things are working simultaneously. I-
Okay.
in multi-threading also we use the same term. All right, concurrency we use, right? So
Yeah.
isolation level ensures that the concurrent execution of multiple transactions, right? Because there is as a one transaction it is this, right? We can call it
Okay.
T1, T2 and T3 and T4, T5 is already there, right? Also there, and they are
Okay.
executing concurrently. If they are executing at the same time, we call it concurrently, right? So
Yeah.
isolation ensures that the concurrent execution of multiple transactions does not interfere with each other. That would be the one thing, right?
Acha.
And each transaction should operate as it is the only transaction that is executing in the system. But it cannot happen,
Okay.
right? Because we usually have 100 database connections, right, in connection pool.
Okay.
So
Okay.
obviously, and if we have daily two or five, 2 to 10 lakh daily active users, then almost every second you will be doing more than 20 30 database transactions, right? Or if not
Okay.
transaction, we'll trying to get some values, right? So that thing will happen. So isolation you cannot get every time, right? But we have to make sure that our system works in a way that it does not interfere with each other. Because I will let you know what are the drawbacks and other things. But before that, before we dive into that, because isolation at different level, read uncommitted, read
Okay.
committed, repeatable read, and serializable, right? And has some issues as well that will be solved with each one of those isolation level, and that would be, and the issues with them is dirty read, non-repeatable read, and phantom read. These are the issues. We are going to cover that maybe in the next class as well. But first, we are going to see the transactions working with these things, right?
Okay.
So let's go back to the system. Okay, so we'll take this example also, right? We'll taking this example also. So the first thing would be, very first thing, let's see what we have data into the database, right? Orders. And let me just use the full screen. Okay, cool. Visible? This
Yeah.
is the data that we have, right? Now I have to start the transaction. So what I will do, I will do begin, right? So it will give me, okay, that
Okay.
as soon as I get this thing, it means my transaction has been successfully started. Cool. And the difference you
Okay.
will see over here is this asterisk will be there, right? Whenever
Acha.
there will be an issue with the transaction, it will be exclamatory mark will be there instead of the asterisk. That will say that this transaction can never be committed, right? We will see all those
Okay.
cases. So now I have started a transaction, right? So what will happen? Let's say I want to get something, right? Select every column, every row, every column from public orders where ID equals to 1, right? Cool.
Okay.
So over here I have written wrong query, right? So over here you can see exclamation mark, right?
Yeah.
Now if I do anything, now I need to do the rollback, right? And it will say the rollback successful. If rollback is successful, then I will get the rollback. If commit is successful, then I will get the responses commit as well, right? So again, let's start. Okay, let's check first the data that we have in our figures, and then I will begin the transaction. Then inside the transaction, I'm just getting data, right? And DQL commands does not impact any transaction, right? Orders, we are taking this data for fun only, right? So inside the transaction, we try to access one data, right? Cool. And let's say I want to update the data. Update public orders set, and let's say amount equals to 10, where id equals to 1. So what I'm trying to do, I want to update the data where the amount is 10, right? And the id is 1. So I want to convert this row or this row into 10, right? This amount,
Okay.
right? Updated. Good.
Okay.
And let's say I'll do the rollback. Rollback
Okay.
successful. Now let's execute this line again. The data is still 100, right? Even though
Acha.
update was successful, but the data was in the buffer, right? Never made it to the permanent storage, right?
Acha.
This would be the first thing. Now we will do another thing. Again, we will start the transaction, and now let's do the same thing. Let's copy paste the statement, right? The amount is 100, right now. Let update public orders set amount equal to 10. Oh, my bad. See, I need to roll back now because 7 rows has been updated, right? So I will roll back, obviously. I'm not going to update them manually, everyone. So let's start again. Okay. Let's start again, begin. And now select, right? And then update. Okay, update, just add where id equals to 1, right? So now if I do the commit, right? Then now it responds back to me, right? That commit has been successful. Now
Acha.
if I do, I am outside the transaction, right? There is no asterisk hash, right? Now normal hash is there, so I'm outside the transaction, right? Asterisk from public dot users, oh my bad, orders where id equals to 1. I knew it already. So I just need to remove this and we're ready to show, right? Now the amount has been updated to 10, right?
Okay.
Because I have used commit. Now coming back to the question you had earlier, if something happens to this, the power outage happens before saving it to SSD, this commit will never receive this commit, right?
Okay.
And if we never receive this commit, then we cannot make sure that the data has been committed to the database, right?
Acha. Okay.
There will be different layers. Okay. So now one thing is clear, right? We have seen what is a transaction, how we do the transaction, right? So the basic thing we have seen. Now the question that we have seen is of atomicity, right? Both statements, both okay. We haven't seen that atomicity item, right? So let's try to update two rows, right, simultaneously. So let's begin first transaction. Let's begin transaction. Then let's see what data we have. Orders where ID in 1 and 2, right? So the user has amount 10 and two user has amount 50, right? So let's
Okay.
update one by one. Update public orders set amount equals to 1 where ID equals to 1, right? Update it.
Okay.
Now what I'll do, I'll update, okay, I'll update 2, right, where ID equals to 2, right? Or let's not update second item, right? Now if I don't do the commit, if I'll do the rollback, right, from here, then nothing will be saved, right? Only a single command won't be saved, right? Obviously we have seen that, right, in the last example as well. So this thing happens, either one will save or nothing will be saved. So if I try, then obviously the second one will not be there, right? The same data 10 will be there. So what now we will do, okay, let's begin first. We will try to violate a constraint, right? Then it will cover both of the atomicity and acid. So let's begin, right? We already have the data, right? We haven't updated it, so it will be 10 and 20. So I will update public orders, right? Set amount equals to 1 where ID equals to 1, right? And I will do the public orders set amount equals to 2 where ID equals to 2, right? Updated. If I do the commit, now both will be saved, right?
Yeah.
Updated. Now what I will try to do is, again I will start a transaction. So now I will update again, update public orders. Okay, one thing more I require, I need to know the order. Okay, order table has this too, not required. So I will update public orders set amount equals to 100, right? It is 1 right now, right? We have updated it, 1 and 2.
Yeah.
Okay, just give me 1 second. Hello.
Yeah.
Okay, cool. So where were we? Okay, so right now the data is not this, right? Let me clean this up first and let me remove this. Let's see the data first, right?
Yeah.
Okay, so this is the data, right? 1 and 2. So what I'm going to do, I'm going to update, where is the update query? Yeah, I need to update 1 with amount 100, right? Successful. I need to update second with amount 200, right? Successful.
Okay.
Now I will try to insert into public orders values, okay. And what I'll do ID 1, ID 100, and then user ID 9, product ID 1, amount 100. Now what will happen now if I try to execute this?
Rollback will happen.
There will be an error, right? No roll,
Okay.
you will not see any rollback, right? Error, right?
This is a wrong
Error.
one. Foreign key is not there.
Yes. So what happens over here? You can see, right, exclamation mark.
Okay.
Right now, whatever I try to do, whether I try a rollback or whether I try to commit it, right, it won't commit. It will do the rollback only. I'm trying to do the commit, right? See, I will say that okay, please go and try to save it into the permanent storage. And what it's saying, no, I have rolled it back.
Okay.
Okay. So this will be the example. I mean, earlier we have completed that both will be saved, both data will be updated, right? Where we have used 1 and 2 values, updated these values inside the transaction. So we have seen that both values will be updated, right? And we have also seen that both value will not be updated, right? Because there is an error. And why there is an error? Because of the constraint failure, right? And that,
Okay.
but that constraint failure preserved our consistency, right? Otherwise there will be an order which has no user, right? Because there was no ninth user, right? Only 1 to 5 users we have in our system right now. So this is the thing. So right now we have seen an example of atomicity and consistency, right? And this is also an example of, I mean, the earlier when we have completed the 1 and 2 value that we are seeing, this 1 and 2 value that we are seeing over here is an example of durability as well. And we have been seeing the example of durability, right? Because this data, when we have started this session, right? So at that particular
Okay.
time I have switched off my system multiple times, right? But still the data is there, right? Today, no, we haven't created this data today. It was there, and
Yeah.
it has been through multiple not system crashes, but at least power outages or the complete shutdown, right? Restart, reboots.
Yeah.
Then too the data is there, so durability is always there, right? Clear till now?
Yeah.
Okay.
Atomicity is clear. Yeah.
Okay, so why not consistency is clear? We have covered.
With that, I mean, the earlier example, that bank example that you gave, and here we are only the one that you gave. It's like we have put a constraints to avoid a wrong type of data to be entered.
Yes. So
Uh,
that will be the consistency, right? The data will make sure that the database system is consistent or not.
okay, I mean, the transactions has to happen, right? Something has to happen at the transaction level that should lead to consistency. I mean, these two examples.
Not at the transaction level. We are just using the transactions for telling the ACID properties, right? You can use it without the transactions as well. But if you try to use it without the transactions, and if you try to answer without a transaction, the second thing you are going to get, what will happen with the transaction? Atomicity you have to use with the transaction, right? Or
Yeah, that
or how
I
we will give the answer? That a group of statements will be treated as a single indivisible unit, and all of them will be executed or neither of them will be executed, right?
yeah.
So instead of answering in a long way, you can directly say, so a transaction will be treated as a single unit of work, and it will be committed or will be rolled back. That's it.
Okay.
So that's the difference. Consistency will be, I mean, if you are saying that okay, we are just using constraints, so what else will you use? We want our database to be in a consistent state, right? The definition says whenever a transaction is complete, our database should move from one consistent state to another consistent state. So what is the consistent state? It will depend on our business logic, right? What is consistent and not.
Okay. Okay. Okay.
Okay, this thing you should have answered on your own, but cool, no issues. And the durability and duration, okay, it's not duration, durability, right? So durability is a simple thing, right? Whenever I'm trying to commit something, or I want to save something, or I have executed a query, then the data should persist, and I should be able to get it anytime later I want, right? This
Okay.
is will be the durability. Now comes the most important thing, isolation levels, right? So let's remove this. Now we are already above this. We have seen the working example as well. So this will work with the only RDMS at school. We already know this as well. So in atomicity, now isolation level, what it says that there is a one transition, right? Okay. So there are
Okay.
isolation. There are, first thing is, there are different isolation levels. There are different isolation levels. First is read uncommitted. Second is read committed. Third is repeatable read, right? Fourth is serializable. So the one thing that we need to know, first thing, that this is sin, right? You should be fired if you try to use this, right? And you should be fired if you use this and don't know what will be the consequences of this, right? And the second thing, read committed is the default. Okay.
Okay.
And read repeatable we'll see later on what is read repeatable. So what eventually ends up happening, when a transaction level is at read committed, right? Let's suppose there are two transactions T1 and there is a transaction T2. Now we are aware of transaction, right? What is a transaction? A group of statements bundled together, and due to the atomicity, what will happen? Either all will be executed or none of them will be executed, right?
Yeah.
Cool. So the first thing what we want to do, let's say that again bank, let's take an example of bank, right? Okay, you like the bank example, but it is the worst example that one can use, because follow-up questions are such that okay, so we don't take the conditions criteria that we are doing the transaction to a single bank application, right? Single bank we are doing the transactions, and also monolithic database architecture we are. Okay, so the thing is, there is a user A, right? I want to subtract 100 rupees, right?
Yeah.
And what will I do? I will add 100 rupees to the base account, right? Cool. Now if the transaction 2, and where this data will be meanwhile before the commit?
Before the buffer.
Yes, cool. Let's suppose a read uncommitted isolation level says that I will read the uncommitted data, right? So now we know that we will read from the buffer, right? So what eventually happens if the T2 says add in the A account 100 rupees, right? So how much data it will read? Let's suppose that A minus 100 will be 900. It has the 1000 rupees, right? Then after this it has 900 rupees, right? And initially let's see that A has 1000 rupees initially, and B has 200 rupees, right? 2000. Okay, so what will happen after this line? If I try to add 100 rupees again in the bank account of A, then what will happen? It will read the 900, right, instead of 1000, because it is reading from buffer.
Okay, yeah.
Right.
Okay.
So what amount it will make? I mean, let's take some other amount. Let's take 200, right? So it will make it 1100, right?
Yeah.
And let's say before adding to this amount, before execution of this line, it's rollback, right? Rollback. Now you know what is rollback, right? So it rolled back. Cool. And what happens after this? That this 1100 has been committed. Cool. So what will happen? Cause the amount never reached to the B's account and the total amount, so that means the transaction has failed, right? Because it's rolled back. So 100 rupees was never deducted from his bank account, right? So the total amount should be 1100, right?
Yeah.
But after the successful commit of T2 transaction, the total amount will be 1100, right? So there is a loss of 100 rupees, right?
But
If two transactions are working simultaneously and they are reading data from the uncommitted, I mean they are reading the uncommitted data that would be the from buffer, then this thing will be happen, right? It is called dirty read. Okay, I have to why? Okay, cool. I have to check the recording again, right? I don't know how much data is there. Cool. So where were we? We were at this thing. Okay, my bad. Where are we? This thing. Yes. Over here, what we have seen right now, we are seeing an example of read uncommitted, right? This is an example of read uncommitted. So over here, read uncommitted, what's happening is transaction T1 is writing something, updating some value, then T2 will read from the buffer, right? And if T2 will read from the buffer, then what will happen? Eventually, the committed data can be wrong, right? Like this happened, right?
okay, yeah. Achha. If
So
it will
this-
read and commit, yeah, it wrong will happen. Yeah.
Yeah. So this thing is called dirty read. Okay.
Yeah.
So there are multiple issues with all the isolation levels, right? So one thing is we have seen dirty read, right? Next thing that we will see that another issue with this is non-repeatable read. Okay. And now what is non-repeatable read? Let's suppose this is a tender website, right? And there are 10 users. Okay, now let's suppose there was a bug in tender, and users with less than 18 years of age were able to create the profiles, right? Which is not legal. So eventually the developers has to revert this thing, right? Whoever the users are with age less than 18, we need to deactivate their profiles. So the T1 transaction, what it will do, okay, let's say the T1 transaction start first, right? Now we are seeing the issue we are seeing right now. In read uncommitted only we are seeing, right? But the other thing we'll see. Over here it will do that get users less than 18 years, right? In this thing, right? And let's suppose it gives 20 users, right? Or let's say 10 users it provided. Cool. Now what it will do, now I have to perform multiple operations, right? First thing I will do is before deactivating their profile, I will remove the matches, right? Remove matches. Cool. And then other thing I will do, deactivate profiles. So the query is get active users, get active users with age less than this, right? Cool.
Okay.
Now let's take an example. This given 10 users, right? And meanwhile, what happens? One user with less than X years of age, he updates its profile. Let's say a user A, user U1 updates age to 10, right? To 25. Cool. So what will happen once you get those users, right? When you get the users and then you remove the matches, right? Then again you get the users and you deactivate the profile, right?
Okay.
So what will happen? The next time you try to get the users, you will get the 9 as an answer, right?
Okay.
Because
Yeah.
T1 transaction has updated the age of one user. Now what will happen? You have removed the 10 users, right? You have get the 10 users, you have removed their matches, right? But deactivated only 9 profiles. One is still left, right? This is again issue with us with the system, right?
Okay.
So if I am getting, I mean, this is one thing, right? Let's suppose I have to provide discounts to a particular user, right? Or I need to provide the cashback to particular users who have ordered a certain item, right?
Okay.
Then I just started, and I started one transaction started and started to provide the refund, right? For
Okay.
those products who has not been delivered yet, right? And let's suppose that during that particular time I have done one thing, that I have deactivated the product, and meanwhile some other transaction comes and do some other task, and then what I will do, I will remove the product, but I will make that product as delivered as well. Now there will be an issue that I need to stop 10 products, right? I need to remove 10 products. So I disable 10 products, right? And then I need to cancel those products as well, right? Cancel orders of those products as well, right? So what eventually will happen that I disable the product first, right? Cool. So that no new order will be created, right? So if I get orders, get products, okay, 10 products, get invalid products. Okay. I'm giving you just another example. So when you try to get invalid products, you disable those products, right? And then you again try to get invalid products, and you have already disabled those products, but you cancelled only 9 products out of 10, right? So one product will still be there, right?
Okay. Yeah.
So that thing, I mean, the thing is, either there might be a chance that one product is not invalid, right? This could happen, right? Someone has manually updated it because that one product is not invalid. So
Okay.
if that happens, then what will eventually happen? Okay, then what will eventually happen is, okay, this is once again, okay, I'll call him later. So what eventually happen, either if the product is valid, then I should not have disabled the product, right? And if I disable the product and the product is invalid, then I should have cancelled their orders as well, right? Both things should have done, right? Otherwise this is again inconsistent. This transaction has become inconsistent because once I have done some operation on X products, and the next time I have done some operation on Y products, right? Now this is invalid, right? So this is called non-repeatable read. What it means, if I run the same query twice within a single transaction, and every time I get the different answer, then it's called non-repeatable reads. Like within a transaction, you are reading the same data again and you are getting the different data, then it's called non-repetitive read. Cool.
Acha.
This is second issue. How we solve it, we'll see it later on. And the third issue is called phantom. Now taking the same items, right? That there is T1 and T2. Let's suppose what I'm doing, instead of this, get active users, right? Less than 18 years of age, right?
Okay.
So what will happen? Let's see that a new user has been inserted, right? Insert user, right? Insert user U11 2. So what will happen over here? You will get 11 users, right? Because we are reading from uncommented data, right? So we will get 11 users, right? Now what will happen? Instead of this, let's say that we will roll back over here, right? So what will happen? We get 11 users. We'll try to remove 11 matches, right? Users of 11 matches, and then we try to deactivate those users as well, right? So in this particular case, we are trying to remove the user that does not exist, right?
Yeah.
Okay. So we are trying to run a query which does not exist, or which the value does not exist. Right? User ID 11 does not exist. So we cannot update the query, right? So this will be the one thing. If we want to delete the query, then again the user does not exist, right? This is the thing that we get. This is called phantom read. Something does not exist and we try to operate on it, right?
Okay.
And the other thing also can happen, that over here the users was 10, right? Instead of insertion, let's say that over the 11 users are there, and I will delete the user, right? Instead of insert, I will delete the user. Let's say that user 10, and there were 10 users. Right? There were 10 users, and I will try to delete the user 10. Then what will happen? I will remove the matches from the 10 users, right? Because I already have these things, right? But if I again try to get users to deactivate, then I will get only 9 users, right? And what will happen? Okay, the rollback needs to be done over later here. Rollback will be here, right? Then what will happen? I will get only 9 users, right? Because over this transaction is saying that I have deleted the user 10, right? So don't work with it, right? So what will happen? I will not deactivate the user with the ID 10, right? But and so that profile with age less than 18 in the tender will be still active, right? Because this transaction has been rolled back, right?
Okay.
This is called phantom read. I have read something that does not exist. It will happen if insert query over there in a transaction which has not been successfully committed. Or what I can do, I will not read someone that exists. That will be happening with the delete query if I'm using, right? So this read uncommitted has these 3 issues, and it is very obvious that these issues, dirty read is the most important and mostly bad one, right? So we never allow this thing, read uncommitted, never allow it, right? And also, if in the Hibernate, in the this Postgres, the default data type, the default isolation level is read committed, right?
Okay.
Because the repeatable read and serializable, it usually takes the logs and it will make the system slow. So that's why the default is read committed, and most of the operations are done by the read committed only, right? In only few cases we require read repeatable, and in almost negligible cases we require serializable, right? And serializable can take the log up to the database level, right? Table level, database level. It can even stop the read queries as well, right?
Okay.
Let alone the update or delete, but it even stops the read query as well. It depends on your query, how you are writing the query. It can take up to the database level log, so that's why never use it if you don't know how to use it and what impact it can have, right? and this is blocked, right? No database have this right now. At least Postgres does not have it. Even if you try to check on Google that read uncommitted not working in Postgres, then you will get the article that Postgres does not support SQL standards read uncommitted isolation level, right? Instead, it will be treated as isolation level as read committed only. If you even try to make it read uncommitted, it will show that you are in the read uncommitted, but it will be still work as a read committed, right? So we will end our session here, but I will just let you know from where we are going to start tomorrow. First of all, we will try to see the transaction levels, right? We haven't seen the transaction levels, right? So transaction isolation level, right? So read committed is the default one, right?
Okay.
So now I will close this recording first.